Hey, sixth graders. So let's go through and work on some of our notes for this unit. So sometimes we'll do notes together. Sometimes we'll do them this way where you guys just do them on your own and we save some of that live class time to talk about some of this stuff to make and clarify to make sure if you have any questions or you need some further explanation that we have the time to be able to do that in those live sessions. So what you see here is your layers of the Earth document that you guys can get from Google Classroom. This is called a guided notes document. So throughout the year, we're going to do notes in a bunch of different ways because I like to kind of change things up so that it's not as predictable and boring. I also like to be able for you guys to sometimes learn different methods to see what you kind of like, because eventually one day, somewhere in high school or college, someday, teachers aren't going to tell you how to take notes anymore. They're just going to kind of talk, and you have to take notes and organize them. And so by seeing a couple of different ways of how to take notes, I'm kind of teaching you different ways that maybe there's one that you like. All right, so this is a guided notes where I'm just kind of modeling for you how outlines work for a note structure. So you'll notice here at the beginning, there's a Roman numeral 1 for a main idea. The main idea for this is the layers of the Earth. And then you have subheadings that are the big capital letters. And every time something is indented, what that means is that it is information that relates back to the letter above it or the number above it as a general statement. Okay, so A1 and 2 here relate back to whatever this note is here on A. All right, and that's how they work. And it's a good way with indentations and an outline numbering system to kind of keep everything organized so it's easy to see as you go through it. So let's go through and talk about some of these layers of the Earth. Wait, where's me? I don't see my face anymore. Maybe I probably have to do this. There we go. Okay. All right. There I am. All right, so as we go through this here, I don't necessarily pause here. I'll tell you guys to pause every now and then, or after I go through and talk about something, you can just kind of pause at your own pace to make sure that you are filling in the doc, okay? So you can either split your screen so you have this and the doc on another window if you want to do that, or you can just watch me, then hit pause, go over to the other tab, fill out the information, come back. It's totally up to you. Another way to do this is some kids like to listen to me go through the entire slide, then they pause it, and then they type in all the notes to the other side. That's fine too. The only thing you cannot do is you cannot just pause it, fast forward to where the slide is full, type in everything, and then move on. And then you miss me talking. The whole point is that you need to hear me explain some of these notes. The notes are just the main ideas. They're not every single detail with it. So you need to be listening to me. That's part of the whole reason why I record these. So listen and take the notes. All right, so let's talk about the structure of the Earth. We've already done this a little bit in class. Earth is divided into layers based on density of materials. The least dense is the thing that is up at the top, so that is the crust. Crust is made out of some of the elements that are in minerals such as silicon, oxygen, magnesium, and aluminum. The core in the center of the Earth is the most dense. It's made of metals, iron and nickel. Heavier, denser materials get pulled to the center by gravity. And you have these three main compository layers: the crust, the mantle, like we talked about in class. Okay, if you have not been pausing as we went along, please pause now, get caught up on your notes, and then come back. All right. That Earth layer, the next thing on there, that rap, I'm going to play for you guys in class. It's a pretty funny song, actually, about the layers of the Earth. All right, as you're following along, we're moving on to the next section, which is Earth's interior and the seismic waves. Earthquakes produce seismic waves which travel through the Earth. You might say, well, wait, why do we even care about this? What's going on? Well, lots of times people wonder, how do we know about the layers of the Earth if we've never actually gone to the bottom, right? And they talked about this in the Ed Puzzle for your homework, and so hopefully you have a little bit of knowledge on this now. And there are different methods that we know, and one of the big one is earthquakes, okay? We are able to measure and interpret the speed and path of the waves as they travel through the interior of the Earth when an earthquake occurs. And we use these machines called seismographs. And we usually think of seismographs used specifically just to help us figure out like where did the earthquake happen and how strong is the earthquake and all these things. And that's true. Those things help with that. But the other thing that they can show us is that we can go back then and look to see the speed of the waves, that the seismic waves that are produced from the earthquake, and the path, like the direction, and if that path changes at all. And that tells us about the structure of the interiors of the Earth. Okay? And so what we see with that is when an earthquake happens, that's right here, the epicenter, and the waves travel, you have these two different types of waves. They're called P and S waves. P and S waves. And we're going to get into this a little bit more specific later. Now, you might think that that stands for speed and path, since I just talked about that. It does not. P is primary, meaning those travel faster, and S is secondary, meaning that they come second, so they're a little bit slower. And there are two different types of waves, and we'll get into all that later. But with P and S waves, when we look at those on a seismograph, we can see that sometimes the speed of those waves and the direction or the path of those changes. So as the waves go through from the surface through the center of the Earth to then come out on the other side, a seismograph that is over here can still detect this earthquake that happened here, but what it's going to see is that for a very specific reason, okay, we do not have any S waves over here. The only thing that comes through are the P waves. The P waves are the yellow ones, the yellow arrows, right? And that's because of a characteristic. And one of the characteristics of S waves is that they can only travel through solids. And so the crust and the mantle, that's all solid. Even the inner core is solid. But we learned that the outer core is liquid. And so because this outer core is liquid, when the S wave hits the outer core, okay, those get bounced or absorbed, actually. Okay? And so then they don't come through on the other side. And so when that happened, scientists were able to make the conclusion of, oh, there must be a layer of the Earth that is liquid. And so that's how we know a lot about what the layers of the Earth are made out of, what their state of matter is, because of these S and P waves that travel, these seismic waves that travel in earthquakes. Okay, pause the video if you need to. Let's go through now and talk about the crust. Let's talk about the crust. All right, the crust is the top solid layer that forms Earth's outer skin. What we haven't talked about yet are that there are two types of crust, okay? And I might have mentioned this a little bit in the reading when we did the breakout activity with the groups, but this is really important. One type of crust is made out of a certain type of rock, and we call that the continental crust. So that's the crust that above it land is, okay? So solid land that we think of in terms of like mountains and dirt and soil and all these other things, right? This continental crust is the thicker of the two crusts. You can kind of see it here in the picture. It's this light brown right here. And it is less dense. So even though it's thicker, it actually has less density than the other type of crust. Okay, so that sometimes is a little bit opposite, and kids get that confused. Continental crust is thicker, but it's less dense. It's older, which is why it makes it more, which is why it's thicker. Okay, I'm sorry, which is why it makes it thicker. And then the other type is the oceanic crust. Oceanic crust. Okay, the oceanic crust is thinner. It's pretty much the opposite here is what you're going to find. More dense and younger. Okay. Ocean crust then is what you would imagine is the type of crust that we find on the ocean floor underneath the water. All right, that's the crust. The least dense of all the layers, but there's two types, continental and oceanic. You need to know those two layers, and you need to know the differences. Moving underneath the crust, we come to the mantle. Okay, the mantle. Mantle is also made of rock, like the crust is. It's hot. The rock is even more dense. That's why it's beneath the crust. The mantle takes up the most space of all the layers. Okay, so it has most of Earth's volume. The core, the central part of the Earth, it's below the mantle. It's in the center. It has most of Earth's mass. So even though it doesn't take up as much space as the mantle does, it does have most of Earth's mass. A big difference for the core compared to the other layers of the Earth, the core is made of metals, not of rock. The crust and mantle are made of rock. Core is made of metals, specifically iron and nickel, which we've seen now a number of times. Okay, last thing is the physical structure of the Earth. So one thing that we know is that as we get from the surface down to the center, we know that the Earth's temperature increases, the temperature in those layers increases, and the pressure definitely increases. So what happens is it causes the layers of the Earth to change their phase or their state of matter, right? Okay, we have these 5 mechanical layers of the Earth that we talked about in our reading. First is the lithosphere. The lithosphere is the outermost. It's cool, rigid, brittle layer of the Earth. It includes the crust and the very top part of the mantle. The next part of the mechanical layers, the next layer is the asthenosphere, and it's in the middle. And it's this hot material. It's still rock, but it's like this, like not quite melted rock, but it's really close. So it's soft and it almost acts like a liquid, okay, but it's not, okay. So sometimes people think of it like almost like a jelly, right, that you would put on your peanut butter, okay. It's like this oozy kind of hot, soft layer that can move a lot easier than just like regular solid rock could. The mesosphere, okay, down in here towards the lower end then. It's hot, solid. It's the main part of the mantle beneath the asthenosphere. It's rock again. And then we have the core, but we now split it into 2 layers, the outer core and the inner core. Okay? The outer core is a liquid layer, and it makes sense because it gets so hot as you get towards the center of the Earth that metal melts. And then you have the inner core. Now, the inner core, this is what might get a little bit confusing, and you might be asking yourself, well, if the outer core is liquid, because it's so hot, it melts, why isn't the inner core liquid? Because it's even hotter in the inner core. And the answer goes all the way back to this first bullet point here. It's not just the temperature, it's pressure. Pressure can affect states of matter as well. And so because the pressure is so great at the center of the Earth that it doesn't allow that solid to turn into a liquid. It holds those particles together nice and tight so that it stays a solid. So the inner core is solid metal because of the pressure. The outer core is liquid metal because of the temperature. The pressure isn't quite great enough to keep it together as a solid. Okay, and that's the last one. Too much pressure to melt. There's just too much pressure in that inner core to melt that metal. Okay, pause if you need to. Okay. That's the end of this document for now. This is something that's going to be important. These are part of your notes. Okay, this is really quickly that I went through these. Okay, we normally would do this in probably 2 different class periods, but that's okay. We went through them quickly in this. You have the notes down, and we'll refer to these notes and talk about them a little bit when we have our live sessions. Okay, so make sure you have your doc filled out. Rewind, rewatch if you want to rewatch. If you thought, man, this went really fast, I want to just kind of go back and just listen and not worry about the notes. You can do that too to review. And then we'll talk about this stuff more in class. All right, thanks. Have a good day.